So my name's Strecker, like you said. I started at Code Level about 3 years ago, and I've been working at QSR. Unfortunately doing C#. It pays the bills, but I do Python at home for my own projects. It's just muscle memory now. Just sit down at my desk at home and just make a new Py file. Yeah. It's so versatile and useful, and I used it a lot at my old jobs to make scripts for other people to use, and that kind of led straight to this talk. So we're going to talk about a Python user interface library called Tkinter. That's what everyone says it's pronounced as, but I'm definitely going to screw up and start calling it Tkinter here halfway through. So what is Tkinter? It is its biggest selling point, in my opinion. Well, two big selling points. One of them being it's completely cross-platform, not only functionality-wise, but on each system, each OS, it'll look native. It'll look like OS X buttons when it's run on a Mac. Same script, send it to somebody else. It'll look perfectly at home in Linux. Same with Windows. Even the difference between Windows 7 and Windows 10, it'll look like it was built for that system. That's mostly thanks to an add-on called TTK, which stands for Theme Toolkit. And that's what manages the theming of the apps, of the widgets, to match the OS that it's running. The other big selling point is it's included in the standard library. If you've installed Python from any of the reputable sources, you've got it. It's ready to use. You don't have to add on any other tool stacks. You don't have to configure anything else. It's ready to go. And that being said, it's also high level. It's not like in the weeds. It looks like Python. The interface on the Python side is Pythonic and pretty easy to get into the flow of designing your UI once you get used to how to lay out your app. So there's a sanity check you can run if just to make sure. You open a command prompt, get into a Python interpreter.
So would that have came with like an Anaconda download or something?
I haven't tested it. I searched. And since it's in the standard library, I would say yes. But the sanity check will definitely confirm if it's on your system. And not only that, it'll help you know the version that's installed there. So if you import Tkinter, nope, not there. Assuming the import works, you can then use Tkinter under test. Test. What did I misspell this time?
DerbyPy store? It looks like a single one.
Oh yeah, you probably Dunders or just have it. Doop, there it is. So it gives you a button. You can see it's got the window, normal, close, minimize, full screen, everything you'd expect. The button is interactive, and the quit button will quit it. One thing to notice about this, though, is those aren't, I'm on Windows 10 here, those aren't Windows 10 buttons, because this little test app doesn't use TTK. So TTK gives it the fully native feel, and you have to import that separately. So, Python, I think in most people's minds, especially considering what it's used for these days, like you make CLI scripts, you automate things that just work behind the scenes. So if you're using Python, why would you want a GUI? For that, you got to consider like what the app's doing, consider who's using it, and then consider yourself how you would like to interact with it. But at the end of the day, it's a powerful tool to have as an option. I talked about my other jobs, automating things for other people. So this was at a photo studio. I was automating like end-of-day stuff, but it required passing in the path to a folder as a string. They've never used command line for anything. So it was even with documentation, there's a lot of hesitation if it's not something you're used to. So a GUI for them would be super helpful to minimize user error. You know, I'd get messages at the end of the day, it's not working, and they'd have a typo, or they'd forget a -p on the flag, or stuff like that. So GUI can kind of minimize human error, make it more approachable for people who you might be designing things for. And also, if there's a repetitive task that, say you want to do something more than once, you don't want to enter the same long string in a command line every time, you can make a button for it in no time at all. So behind the scenes, Tkinter is an interface to a language called, and I've verified this is accurate, Tickle, TCL, tool command language. I watched videos from the annual conference, which is not called TickleCon for some reason. Make sure I was pronouncing it right, but it's Tickle. 42nd most popular programming language as of last year. It's been around for a long time, and actually, if you look inside your Python path, you'll find a folder called Tickle, and in it, TK. There's Tkinter, which is a bunch of Tickle scripts, which are being called by your Python code, which then conspire with some C in the background to work with your OS's window manager. That's how the windows get drawn. That's how the behavior that you expect a window to have, minimizing full screen, all of that is handled. So these are the widgets that are on offer from Tkinter. Clearly there's a lot of them. You can see there's some overlap between, say like there's a label in Tkinter, there's also a label in TTK. They do have different functionality. Again, TTK is the themed. So wherever possible, if you want it to look modern, you use the TTK version of that widget. It's just something to keep in mind. If you're searching for something in the docs about, say, a label, make sure you're looking at the TTK label versus just the plain default TK label. Now, I'm not going to go through every one of these because nobody wants me to read the documentation to them for the next 3 hours. So we can get started with the minimum viable GUI. Basically, this is boilerplate that every one of your Tkinter apps will have. Every TK app needs a root. And this root equals tk.tk. That is basically the window. Like, nothing inside of it. It's the top of the window. It has no content. It has no arguments to be passed to it. It just instantiates the window object. Then from then on down, every widget will be passed a parent as its first argument. So in Tkinter, your frame is your div. It's a container. It also very rarely has any arguments. You can do some formatting like padding and stuff. We'll talk about that in a second. But you pass the root to the frame. So now this frame's parent is root. Now we can start putting widgets in it. So a label is non-interactive text, just a label, like it says on the label. You pass it the parent of the frame. Now the widgets at this level start to have parameters. They're all in Tkinter keyword arguments. You know, text equals hello world. There's a whole list of all of them we're going to get to. And then a button to do something. Otherwise, it's just a sign on your desktop, not interactive at all. Then to kick it all off, to actually spawn the window on your screen, you run root.mainLoop. Check. Oop, no, I do that every time. That can go away. Probably shouldn't put them next to each other. here you can see we've got,
You able to zoom that out?
yeah. Tell me when.
That's good.
Let's get out of the interpreter. Gosh, that's huge. Get this open. Easy to go. Alright, so we've got the root instantiated, we've got the mainframe, roots gets passed to it, so now this mainframe is a child of root. This is what I'm talking about, padding, you can go ahead and set up thing. There's no default padding on anything, so if you just start putting widgets in frames, it's just going to be crowded and pixel on pixel contact between all of your elements, and that makes interacting with them really challenging. Your label, again, pass mainframe. So these are sibling elements, all of these that have mainframe as their parent. Anchor is talking about centering the text, and then you set the text value of the world. That's what it's got to say because it's our first one. And then a button. If we run that, a tiny little window. Now the formatting for this, every element is only going to expand as much as the contents within it. See, the button isn't much larger than the text. The label doesn't have any of its own space that it occupies. And the only reason it's not butting up against it is because these three icons keep it from getting any smaller. And a button is nothing if it can't do anything. So you've got define your methods, and then the button has a property called command, and you pass not the function itself, but a reference to it. So show home button style without parentheses. Because in this case, it is a reference to the function that will be called when the button is clicked. You put the parentheses there now. When this runs and it hits this line, it'll evaluate that function, run it, and then try to return the results to command. And that just won't. There's nothing to work. It's almost always an error. Let's see here, make this button do a thing. Yeah.
Save your file.
Every time. So that call a function that calls old button.grid. .grid is not what we've talked about yet, but the grid function is what actually renders it inside its parent element. It's one of the geometry managers that Tkinter has. So here we've called all three of them. That made those show up when we first run the script. And then the function oldButton.grid then runs .grid. It doesn't have to be done in advance. Running .grid will place it into the parent app at the moment it's executed. Does that all make sense? That kind of organization of keeping things in their parent container? All right. So geometry managers, like I mentioned, grid. Grid is the one I use the most. If you're familiar with CSS, well, first the other two are pack and place. If you're familiar with CSS, grid is your CSS.grid, or like old table formatting from way back in the day. Pack is flexbox in that it is really good at very quickly filling either in a row or in a column. One parent element is not going to do both with pack. Now you could have several rows of parents in a vertical pack, and then each one of those would contain a horizontal pack. But If you do that, aligning the elements between the three rows is going to be really challenging. So grid is kind of most versatile. Place is very esoteric. It's literally placed by pixel in the window relative to the corner. It's hard to kind of keep any complexity organized if you're trying to place things that way. One big advantage it does have is that you can do these relative to each other. So there's one use case that I'm planning on building into my app, whereby you could have resizable widgets within a parent, a click event in the center, you could drag left or right and just shift their relative values. You couldn't do that with grid, you couldn't do that with pack, but with place you could. And it's the only way if you ever wanted to overlay widgets, pack is the only way to do it. Neither of the other two will let you do that.
Did you mean pack or place?
Place. Place is what you can overlap.
Okay.
So the case study that we're going to work through here is this app. So at work, just by chance, we were doing some features related to thermal printers. And if you remember the old Game Boy camera from late 90s, I never had one. Kids at school thought they were cool. You could take pictures, you could print, it had a thermal printer that you could work with. And I just really liked the functionality of a printer that I can send serial commands to. There's a whole Epson command language you can use to interact with them and to do ASCII art and things that it wasn't necessarily designed to do, but I wanted to explore. So I started writing this app. But you can pass, in CLI, you can pass it a string to print, the serial COM port that it's on your system, and the baud rate it's set to. And it'll print it out. So if it's on COM3, and it's 9600 baud. And there it is. In free bookmarks. But that has limitations. There's 40 columns of text on here that you could, place whatever you want inside. You couldn't format that in the command line in real time. You could do it somewhere else and copy and paste, but that's not what I'm looking for. So I've been working towards from that to this. You can send raster data, pixels, to the printer to print. So I wanted that functionality. Couldn't do that in command line without interactively. You obviously have to take a full color image and transition it to 1 bit per pixel because it can only print black and it can only print white. So to get there, we're going to start from recreating what you can do now in the command line, but in an interactive way. So on this phase, we're going to use an entry. That's just one line of text. Button obviously sends a command. We're going to introduce row and column configure. And then a text widget, which is multi-row text. Is that still readable?
Yep.
Back row? Sweet. All right, so we've got our imports. We've got some methods that are used down further. Again, with the boilerplate, the root. This concept is how Tkinter kind of has two-way data binding. You can't pass a like straight from the text box to a variable without first instantiating it as a string var. And that kind of, all it exposes the getter and the setter for this variable that you don't have to explicitly say when I type in this box, assign it to this variable. You just tell the text when you instantiate it that it's going to use com string has its data storage, essentially. And then other things can access it if they call comstring.get. We've got our main frame with the padding, and row and column configure are exclusive to the grid geometry manager. As I said, the rows and columns will expand or collapse to exactly contain what's inside. But should there be extra space anywhere, weight defines how that will be filled. So you want to always have, explicitly say, at least one row and at least one column have a weight of 1, or you're going to get some weird kind of shifting because nothing will expand to kind of fill margins. That's all I did there. And calling grid on the main frame starts it. But there's nothing in, main frame isn't the parent to anything. So it'll be just an empty window. So we bring in a label for the settings component. We call grid on it, and here we're going to start. This is entirely optional for your widgets. The first widget, the default will be column 0 at whatever the biggest row is plus 1. So you could call, you don't have to find 0, 0, but I like to do it in case things get disorganized later. You don't start to forget which column is the first one because you didn't set it. I like to just put it out there without any ambiguity. And this sticky is about how, so the column will be as wide as the widest element of anything in that column. If you have a small label in a different row in that column, it's going to have a lot of space around it. The sticky defines which side to place that element on, or that widget. And when you name all of them, and these are cardinal directions, north, south, east, west, it centers it. Now, kind of recreate that for the label of the actual setting itself. Let's run this so we can see where we're at. But we didn't call grid. Get all that. So you can see here the settings label and the 2 rows that each share the COM port. But you can see they're evenly spaced. At this moment, it's a 3-column layout. You can see 0, 1, and 2-column layout. So that, if we come up here and change the one that gets the weight of the column to column 1, that will take care of the. You can see now this column has expanded, and these 2 aren't going to get the extra space now. So this is a much more interactive layout. It's what you'd expect with the elements being close to each other. And the fold rate. So the text box, and you explicitly state width and height because it's a multi-row text entry. And here we've got column span 2, so that it'll not be limited to just the column on the left. It spans past this one into the second column. And we bring in the button, and you see the command send text to printer. Which up here just handles the parsing the hex codes, and it reads from comstring.get and baud.rate.get, and the text is from textbox.get. So the text box you don't assign to a variable like you do the other 2. It just has its own get and set methods on it. And you have to just state the index, which I guess in Tcl is 1 based, and then tk.end to just whatever all the text that's in the box at that moment. another thing, after the fact, I was talking about putting some padding on everything. You don't have to put it on every single element. You can loop through all the children of any container or any frame. And then this configure changes these grid settings and updates them with whatever you pass to it. So with that in it, it's a little more better laid out there. So we can try that with this awesome snake. Nope, I don't have my print button. Hold up. Need to make just, there's our paddings that got looped through. Like I said, snake again. Let's come 3. Brave new dongle feature.
You said you had 48 rows and columns around along the grid?
Yeah.
And
So yes, these values are characters for this widget.
now your header, you have that many up there too? Above that?
Oh no, this is you can put as much as you wanted it. It just won't display them. You could set it as wider, and it'll actually be as wide as the column that's embedded in.
Okay.
Let's count 3. 600. Right. And an epic bookmark. So these are the other variable classes that exist. You got double bar, int var, string var, and boolean var. It's a little out of character when you're writing in Python to try to think about the difference between int and double. But for instance, if you're, it's just something to be aware of if you're trying to. There's a canvas example here where you can't have 0.5 pixels. That needs to be a round integer, but the input widget has a resolution of several decimal points. So you'd have to manually convert that before passing it to int var or double var. It won't cast it for you. So to add a little extra, this interface is nice and all, but typing in here is really cumbersome. You can typo your baud rate, and you'd have to remember what it is from the printer. There are standardized baud rates. And then typo in com3, you'd have to type it in every time. So there's still improvement to be made. We go to we're going to bring in a combo box. A combo box is the little box you click on. It has a list that drops down. You select one. The values can be dynamically generated or stated in when you construct it, or set after the fact. It can be read-only. By default, it will let you type something in it, which is not expected behavior these days for a combo box. If you have a drop-down, it should be for those specific values and not just anything you feel like typing in it. And you can also disable it if there's no values to select. And there's a binding available that on change, call a function when you select a new option. And a notebook is a really awesome widget. If you look at the example, this raster and text tab is a notebook. And all these are their own frame. And then, so you instantiate your frames just like you would. They'll be contained to the same column and row slot, and they'll switch between them when you click between the tabs. It's a really good way to organize more involved layouts. So I've set up the standard baud rates to be ready to be passed to our combo box. This is all the same code from phase 1. The same boilerplate, buttons and all that. So the notebook You instantiate a notebook, pass it the frame as its parent, just like every other widget. Then you start creating frames that will represent each tab. In this case, the parent of the new frame will be the notebook. You pass that in. And then you add the tab. The add function takes the name of the frame to be associated with that tab and the text is put in the tab. And then you don't forget to call grid on the notebook or none of these. Even though you've called grid on the child, it won't show up because its parent hasn't been gridded. This is the same text box as before. Combo box. Saving. So now, baud rate is a combo box. One thing, if you look at our combo box, you pass the rates, which is that list of baud rates, into it on construction. You set a text variable like we did before. That part's exactly the same as if you typed it in. There's a set right here. You have to explicitly set what it will be when it starts, otherwise it'll be a blank box, which in normal UI, a normal person looking at that, it would look like there aren't any options. You kind of want to have a default value when it opens to let them know it's more interactive. So that's, you just set it to the first item in the list. It'll auto-update when it gets and here you can see the bind. So we haven't talked about bind yet, but that's a way you can capture events that happen within the widget that it's called on. This combo box selected, there's a bunch of these, just a giant list in the Tkinter docs to see what's available, everything from keybinds to mouse clicks and movement and all the normal things you'd expect in an event kind of capture. You pass the, in this case it just prints as an example. As a demonstration. If you select it, it'll print the one that you've just selected. And all the print functionality remains the same. So, a little sidetrack here. The canvas is coming in a second, and it is a monster of a widget, just as you'd expect if you'd used Canvas on HTML or anything. You can draw arbitrary shapes, lines, paths, and Matplotlib has a direct interface that will give you an object of a graph that it's produced that is ready to just hand to a Tkinter canvas, which makes displaying data really handy. Same with Pillow, which is a image processing library. It has a method that will return the type of photo object that the Tkinter canvas expects. You can reference everything that you put there for deletion later, for changing, interacting with, dragging around the canvas, and it's fairly responsive. So let's look at one of those real quick.
So it's sort of a side question. If you want to change the color of a button or something to why is that real simple to?
Every widget, for the most part, has a foreground color, background color, text color, everything you'd expect to be able to change. There's a method for that. The best place, we'll talk about the docs to look that up, just because it's
You can't be expected to know everything.
Yeah. So the canvas, again, you just instantiate the root frame. Probably getting old hat at this point. So the canvas itself, just like everything else, passive parent. You explicitly set width and height just because it's more of a fixed feature. You don't want it to be at the whim of the size of the window. If you have something drawn to it and the window is too small, it's just not going to be a good user experience. Create oval is one of those drawing commands. You pass it. In this, all of these shapes are passed points. This is X, Y, X, Y, which is odd for an oval, but it's a bounding box that the oval will be contained within. So you're not drawing a circle, you're drawing a box. The circle will or the oval will perfectly fill that box. Dash is the type of line type, width is the size of the line, outline is the color. Tags is what I was talking about. You can give something you draw on the canvas a tag to be referenced later by other parts of your code. So if we look at this, it'll be a little more clear. So that's the circle we drew. You see it's 25, 25 up here in the corner, and the coordinates are from the top left. That's the top left corner of the bounding box. 475 is the bottom right corner. Another widget that I've added here for some interactive experience is the slider, or it's a scale. This is what I was talking about. This scale has a resolution, but these are just pixels. So you can see that the slider set the endpoint of this line here. So you could animate anything in a canvas that you draw. You could have it react to other events. And got a setting dialog box that will change the color of the circle. So you have to reference the circle by the tag, and then you can alter or delete and redraw it, but same end effect of changing the color of the circle. Now you can also see in this case I did use pack because I didn't need to spend a lot of time defining columns. It's a frame of the canvas is in frame 1, the main frame, or the canvas frame rather. So the left slider is the first thing. Then the canvas itself is packed in with that. It just automatically takes its place to the right. Then a second frame is at the bottom with the only thing in it is that slider, just to keep it aligned. Now's a good time. We can talk real quick about, we talked about bind and an event. In this case, it's a keystroke. Control Q will call exit, and exit's just a built-in method that's on the root object. It closes the window just like you'd expect. So, organizing more complex interfaces. So each of these squares represents a frame. So frames within frames is kind of, that's the only container available to you to fit a bunch of stuff into different size grids. So this is a 2 grid, this is another 2 grid, this is a big frame, it's just the notebook, so it's 1 row, 1 column. The whole thing is 2 rows, but might be 2 column, and this is column space, and then the 2 canvas objects. So if you're going to get to that level, you're going to start having to organize all the widgets in a more easily maintainable way. The standard way of doing that is to subclass the widget and then call its parent init, which will be make sense in a second. You'll see the code, and that lets you not get lost in the weeds when you try and really add a bunch of stuff into one app. So here's the main app itself. You can see here tkt.tk. This is the root. I've named it the name of the app. You set your init, and the most straightforward way is to call super, because you need to instantiate the actual TK that this is inheriting from. In this case, it doesn't need any arguments, but you still need to instantiate it. Then you can start adding things to it. So in this case, we're adding the title of the whole window. See that here? The title is up here. It is a property on root. Didn't update the name of my title to match my fancy new PY spelling fun that every Python app needs. I did my column configures on it. All of that's super straightforward. We'll talk about menu bars in a second, but that's the menu bars here that let you people expect apps to have. And then you can start defining your frames. In this case, in this root app, I only have the one frame, the main frame that everything else will be contained within, all the normal setups. But here, instead of straight calling a combo frame, or sorry, just instantiating a frame, I've subclassed serial frame, serial settings into its own class. And it inherits from ttk.frame. So when it's passed a parent, the parent is passed to its base class, which is frame. And then you can add your own private variables to it. Well, not private, but the class variables to it. Otherwise, you're going to be really starting to pollute up your global namespace. Global variables are going to start to get hard to keep track of. So at this point, it makes sense to think of frames as components, because each one will have its own variables, its own methods that will act on itself, and it can be passed references to other things if they need to talk between. The print button needs to know the settings for here, for example, even though they're in two different classes. Does that make sense inheritance-wise for why you would organize it that way? And everyone's familiar. Is anyone not familiar with calling super on something that's got a parent class?
There's got to be somebody not. That's a hard one to get.
Yeah. You could work around it by calling, like it's a shorthand, more streamlined way of saying this. Right? Then you'd have to pass self to this too. Self. Naming things is hard. And another thing that I found really convenient is in this in it you can see I'm looking for the quarks. If you're not familiar with quarks, it took me a while to come around to like, oh, this is how I use them. But once you do, it's super straightforward, and it's in the pattern of Tkinter itself. All of these quarks are keyword arguments. These are all keyword arguments. They're all defined here, but they have default values within the class that would have just been filled in should you not define them yourself. So by passing quarks to a init, I can take it all the way down to self.grid quarks. So that way I don't have to come into this file to organize it at the top level. If you look,
Going back to Colin's talk, so then is that a dictionary underlying that? Keys and values?
yeah, you can, for anything here, combo box. So combo box dot state read only. You can alter it self to combo box state equals disable. You could do that. Any of these properties are accessible that way, for sure. So like I was saying, passing the quarks to, this is where the mainframe's components get instantiated. First you pass in self because it's the parent. It's expecting to define its parent. And then all of the placement, grid geometry stuff gets passed all the way down to its grid function. So if I wanted to swap these two components, I wouldn't have to open different files. I could do it all right here. This really helps thinking ahead of how you want your end app to look like and the trouble you might get in. I've I'm sure you can imagine, like, if you have 8 columns and you want to rearrange 3 of them, you have to renumber every one. So you don't want that to be somewhere else. And just in the same way that we did the loop through all the children to set the padding, you could do that with rows if you're really confident about how it was all going to line up in the end. You know, define the rows after the fact, after they've all been instantiated with a loop, and then pass each one the index of the loop. They'd have to be in some sort of data structure to do that, but that'd be an easy way to make your life easier. There's some more binds. One bug I didn't realize until just last night. I was trying to control Q and it wasn't working because my caps lock was on. And every program I ever used is smart enough to have taken care of that, but when you're writing it your own, you realize that is Control-Shift-Q. So you have to bind that too. You could bind these to any of the properties, or not properties, but any of the widgets. They could listen, one widget could listen specifically for one key binding and call its own thing. That'd be a little tricky to keep track of, but we can go a little deeper into the printing tabs because that is a widget or a frame that has its own subframes. So it's very straightforward because it's just a notebook. Instantiates a notebook with the parent. Quarks again to go to grid. And then it has 2 tabs, which I've also subclassed. Canvas one is the raster tab. This one's pretty intense with methods because it involves the image processing part of it. I don't think there's anything special there. So we talked about quarks that pass into grid, parents to super, components for isolation, the menu bar. So the menu bar, every app should have one. It's expected to be able to quit that way. You got edit, you got file menu. That would be one thing that would be, you'd have to explicitly state between OSs is try to, the standard Mac versus Windows ordering of whatever there's an about that Mac has that Windows doesn't have so much, but someone who's paying attention would realize. So you have to first add a menu bar to the root. But it gets a little weird because then you're adding menus to menus. They're not frames. You don't have, this is one thing that doesn't need a frame to be contained. It's going to be stuck right at the top of the root window. You instantiate these 2 menus, so file, edit, they're just menus with their parent being the menu bar, which is itself just another menu. Then you add the cascades for the actual label, file, and edit. And then you can add the commands to the drop-downs for each one of those. So file will have a command exit, well, have a tile called quit that we'll call exit. That's better on the root. I did do it with a subclassed menu. You pass the parent, parents pass to super. The menu file, I mean, say it's obtuse because self.menu file equals tk.menu self. Like it seems circular, but it all works out in the end. I just have a file and a quit in this one. So the settings dialog is an expected thing, typically in GUI apps. Any tk.tk is a window, and any method in your program can call it, and there's another window. It'll have its own root. You'll add your own, add new frames to it, and it'll have its properties, just like anything else. When you're done with it, you call destroy, and that will destroy the window. That'll close the window without quitting the entire app. I've got that example of it in Canvas. Makes a little more sense there. So you can see it just spawns a window. One thing to note, I don't know, some GUI frameworks, this will take control entirely away from the underlying window. I know WPF does that unless you're multi-threading. That's not the case here. They both exist and are interactable simultaneously. So you can see the menu bar gets set up here, sets the commands from the global. And one thing, if you were here last month, the other thing you can pass to a command is a lambda. So you'll notice if you just pass the reference to the function, you can't pass a parameter. It'll be reference, it'll be, if you define that as a function that needs a parameter, you'll get an error when you try to run it, because it won't get past any, it'll say this expected one. So lambda allows you to call the function when the lambda gets executed by the button, and that you can pass a variable either from within itself or a global variable. One good example is in raster tab here. So the buttons, they call lambdas, and the right button will pass +1, the left button will pass -1 to the rotate function, which then will be able to tell which direction it's supposed to rotate the image. Just made it. Select an image. With one method, you can do multiple things based on the way you set it up, the expectations of what it gets passed by the lambda. You can set up custom icons. The default is the little tickle feather. If you've ever been using git bash and it prompts you for a password in a pop-up window, that's a Tkinter interface. It's got the little blue feather. It's just a handy way for them to do that. The entire git bash GUI is built in Tkinter. And also the Python IDE that gets installed with your Python is all written in Tkinter. So that's a fairly complex, lots of windows, lots of settings, a lot going on. It's a really interesting source code to look through, and it's already on your computer when you install Python. It's a great use case example. And you can see that I've got the printer icon on this. It changes the little icon in the corner and down in the start bar here to any ICO file you pass to it. We talked about the binding of the combo box. Any key combination you can imagine you can pass to this to call callbacks for those bindings. And documentation-wise, so Tickle's been around a lot, and around for a while. Since the early 90s. It's 42nd most popular, but I think its last update was in 2006. Their documentation, official documentation is here, tickle.tk. And
it definitely looks like a 2006 book.
Oh yes. And not only that, if you decide to use it, here's all the commands in Tickle. You will have to translate them into Python, which isn't terribly hard. The options are what you pass in the quarks. You can, for button. Which button? The text, that's the button text. So you'd call button, pass it text. You can read about it just like you would. Once you're used to looking at these docs and translating them into Python, it makes a lot of sense. It's awkward at first because look at this, but it's a good source. The unofficial, but the most official unofficial is this website too. I think it's a mid-2000s website, so at least there's that. And it's written in Django, so good for completion. It's got good widget roundup, but even this, it's a work in progress that hasn't been updated recently at all. But it's got a really good walkthrough of history, why it exists, why it was created. And then obviously Python's, because it's in the standard library, Python has its own documentation on its implementation in Python. And one other thing I hadn't realized until recently is that I think it was also last month when it came to the function talk. Anyone else get this bug with Visual Studio in the last update where the terminal's all half invisible until you type one thing? These Tkinter functions have the most comprehensive text when you pass them to help that I've ever seen. So if you held Tkinter dot button, nope, not button, and not helped. Everything from the standard options, this time in Python, not Tcl, the constructor, expectations. It's just a really good source. It's weirdly better than Python's own documentation, is this right here. So you pipe that to a text file, and you've always got your docs.
That's a good segue into a use case that I have. If I'm working on some program and I spit out a bunch of numbers, and it's like 10,000 numbers by accident.
Yeah.
Can I shoot that to a window and have it just kind of scroll inside there?
Oh yeah. There's a message widget that's designed for like real-time scrolling feedback. You can add a scroll bar to anything. If you know how many there are, you can have a progress bar.
I don't really care at one point. I just don't want it to make the terminal thing go 1,000 lines.
Yeah. So there's even a command, essentially like a command prompt widget that will let you interact directly inside your app, typing into that's how the Python IDE does it. And if that wasn't too much all at once, that's all I got. And unless there's any questions. Sure.
Are there any projects that overlay on top of this would allow you at least to start your frames and all that in a more graphical sense to get that down into creative mind and then turn around and start playing with the numbers and labels?
For the other, there's obviously other GUI toolkits that Python uses. Those are all well supported with like third-party apps that let you drag and drop design that will then spit out the code. Tkinter, I haven't seen one. I start with an index card, kind of like map it out in advance. Gridded index cards are the best thing ever. I also like to use them because ratios of things that we use every day are familiar. So a 4x5 ratio of your widget will just feel comfortable on screen. It'll be approachable. I think we've all used some app on the internet that just didn't look right, but it was functional. But some of those little cues of relating it to shapes in the real world that we are comfortable with, 16 by 9, 4 by 5, 8 by 11, can help keep you focused and not wind up with a really tall, skinny grid by the time you've added everything to it.
How good is it accessibility wise? Like, my screen here has working on,
That I don't know. You could loop through and globally change contrast. You could have a method that will change all of your widget's background colors, like a dark mode or a high contrast mode, and it'll. I haven't checked. I think it would respond to Windows' own high contrast visibility mode, but I haven't tried a screen reader. That's a good question.
In your program, I don't remember the setting name you had, but I saw tear off. What was that in reference to?
Oh, yes, good question. There are some artifacts of. Let me go to this in Canvas. Artifacts from. I've never used an interface that used this, but I get kind of in Photoshop. If you have a tool pane, you can grab it and pull it out of its lineup and have it be wherever. At some point in history, you could do that with menu bars things. You could pull file off of the menu bar and put it in the corner and always click, save, quit.
So kind of like a web browser, almost somewhere where you can pull a tab off and then.
Yeah, but even though the UI marker for that is like a receipt, like a dashed line across the top of your menu bar, which looks awful. So you have to set that as off in your root to make that not show up.
Yeah, you mentioned WPF. Have you made apps in that? And
Yes.
if so, how does it compare, like, just generally working with Tkinter versus WPF?
WPF is a lot more opinionated about how you have to do everything, and it's very rigidly kind of MVVM or MVC depending on how you set it up. This you kind of have to roll your own model view controller, which you can do. There's one part where I had the buttons on the raster tab. It has. Here's my buttons. Print buttons. I have this bind buttons method where I can call from the other frame that has the data that it needs to send the data to the printer, and I can pass references to those functions to these buttons. I don't have to have crisscrossing data. These will just call an external function. The data will stay over there, and it'll keep things from getting all messed up. And the binding's a lot easier in Tkinter. And WPF isn't very cross-platform. So. And there's no XML, so another plus. All right. Thanks for sticking through to the end.